So in this video, we're going to do this question, which is an integration question. We're taught to find the integration of x squared divided by 4x squared plus 12x plus 13. So as seen from the question, that the main ways of integrating, see that you can use substitution, or you can use trig substitution, or you can solve this question into partial fractions, then you come and integrate. But the easiest way to solve this question is it's a combination, but the first thing you have to use is use substitution. But from the denominator which I've been given, which is 4x squared plus 12x plus 13, we're going to complete the square. So we do some manipulation so that before we use substitution, we have already simplified the denominator. So if you have 4x squared plus 12x, so if you complete the square of the denominator, you're going to have something like this. So first things first, you have to factorize the 4, and you remain with 4x squared plus 3x plus 13 over 4. Then the next step is obvious. You have to, the coefficient of x, you have to add and subtract the square of the coefficient of x. So this will just be 4x squared plus 3x. What's half of the coefficient of x squared? Half of 3 is 3 over 2. So you're going to add and subtract it. Then you square it. So you end up with something like this. And after which you're going to collect these two. So you have x plus 3 over 2 squared. When you square this one, become negative 9 over 4 plus 13 over 4. So when you evaluate this part, you're going to have 4 is a common denominator. So negative 9 plus 13, which is 4, divided by 4, which will give you as 1. So you're going to have x plus 3 over 2 squared is 1. So for this part, we have completed the squares for the denominator. Now, after this, now you can use substitution. Let's say u is equal to x plus 3 over 2. The x plus 3 over 2 I've gotten from this part. This is a part I'm going to I'll let it be equal to u, so that when I place in the original integral, I do some manipulation so that I can solve it. So from this, we know that du dx, when you differentiate it just be dx, when you differentiate x it will just be 1. So du is equal to dx. Then we can let, since we know that u is equal to x plus 3 over 2, that means x is equal to u minus 3 over 2. So from this, we can now replace into the integral, the original integral. So let me just rub this. And from after completing of the squares, we had something like this: x plus 3 over 2 squared plus 1. Then we said let u be x over 3 over 2, and our x is u minus 3 over 2. And when you differentiate this, we are going to have du is equal to dx. And from our original integral, which is x squared over 4x squared plus 12x plus 13 dx. And from this, we replace this part, the completed the denominator which was done in completing of squares, and the u and the x. So from what you have, we're going to have so for the x, we say u minus 3 over 2 squared. In the denominator, you know that you have put it in complete of squares. So you have 4 x plus 3 over 2 squared plus 1. Then we know that here there was dx. And when differentiated, we found out that dx is equal to du. So we can just put du here. And from this, we can simply factorize the 4 from here. So we're going to have something 1 over 4 u minus 3 over 2 squared over x plus 3 over 2 squared plus 1 and u, and it's supposed to be squared. And then the other part, I'm supposed to replace u here because everywhere where there's x plus 3 over 2, there's supposed to be a u. So 1 over 4 u minus 3 over 2 squared over u squared plus 1 and du. And the top part you can simply expand it. You're going to have something like u squared plus 3u plus 9 over 4 over u squared plus 1 and du. So from this, we almost have the answer. The only thing, you just have to divide through the denominator into the upper part. We can just separate the parts where there is u squared divided by u squared plus 1, negative 3u divided by u squared plus 1, n plus 4 you divide by u squared plus 1. So may just clear this so that we get more space for integrating what we remain with. So we had 1 over 4 the integral u squared minus 3u plus 9 over 4 u squared plus 1 du. So when you divide through, as I said earlier, you remain with it u squared over u squared plus 1 minus 3u over u squared plus 1 plus 9 over 4 over u squared plus 1 du. We're almost at the answer. The only thing that we need to do is integrate this, but from what you know, 1 over u squared plus 1. This is just simply an inverse of u, and when you have u over u squared plus 1, this is just natural log u squared plus 1, and you have to put the half here. But as seen, there's this part. These ones are already cutted from what I've said. Now there's this part here. There's this part. You have to do some manipulation for you to get to the final answer. Quite right for this one and this one. You can just use these two and reach the answer. But for this part of u squared over u squared plus 1, you have to do some manipulation for you to get to the answer. So 1 over 4 integral u squared over u squared plus 1 and minus we know that the integral of this u over u squared plus 1 already said it's in this. So we can just simply replace it by negative 3 over 2 then we say ln natural log u squared plus 1. And for this other part, for 9 over 4, it's just simply 9 over 4 tan inverse of u. Now we have remained with this part. This part already integrated, so the only thing that remained is this part, which you have to do some manipulation for it to reach the answer. So can just use the direct way of saying, for instance, if you say ln, you can't use ln because this one is u squared. What are you going to say? You're going to introduce a factor, you add and subtract it, there should be 0. So you want it to compare to this part, the bottom part. The bottom part is u squared plus 1. So even the top part has to have u squared plus 1. So now whatever you add and subtract, it should be equal to 0. So we say 1 over 4 1 over 4 integral u squared over u squared plus 1. This part will just leave it since we already reached already integrated it. So we just focus on this part which we still haven't remained, which has remained that for integrating. So since you have the denominator is u squared plus 1, so you can say u squared plus 1 minus 1. In which case, plus 1 minus 1 is just 0. So it's like we have introduced something, but it's equivalent to 0. So in this case, we have 1 over 4 u squared plus 1 minus 1 over u squared plus 1. So when you divide 2, you find that you're going to remain with 1 over 4 u squared plus 1 divided by u squared plus 1 is just simply 1 minus 1 over u squared plus 1. Now this is an easy integral which we can easily integrate. The integral of this will just be u minus remember that this part is just equivalent to tan inverse. So minus tan inverse of u, or this 1 over 4 was supposed to remain. What I was just focusing on was this part of u squared plus u squared over 1. So let me just erase this so that we write the final answer in a proper way. So I have 1 over 4. Let me just rewrite it. So from u squared over u squared plus 1 minus 3u over u squared plus 1 plus 9 over 4 over u squared plus 1 du. So when you integrated this part, you find that it's u minus tan inverse u minus 3 over 2 natural log u squared plus 1 plus 9 over 4 tan inverse of u. Then at the beginning, earlier on we said that let u be equal to x plus 3 over 2. So we can replace back the value of u, since the question was in form of x variables, not u. So at the end, you have to replace back so that you find the final answer. So this should be 1 over 4. Wherever there is u, you have to put x plus 3 over 2. 3 over 2 minus tan inverse x plus 3 over 2 minus 3 over 2 natural log x plus 3 over 2 squared plus 1 plus 9 over 4 tan inverse of x plus 3 over 2 and brackets plus c since we're integrating. Then one last part, there's some common thing, there's tan inverse here, and also there's tan inverse here. So negative 1 plus 9 over 4, answer is just simply 5 over 4. So collect the like terms, you're going to remain with 1 over 4 x plus 3 over 2 minus and plus 5 over 4. Let me just rub this. So plus 5 over 4 when you add these two, an inverse of x plus 3 over 2 minus 3 over 2 natural x plus 3 over 2 square plus 1 c. So this is final answer for this question, and you're going to access it on the Pen2 app when you upload it.